This lesson is on lines and angles. Take a minute to read over the learning goal. Find where you are on the scale before we start the lesson. Let's take a look at some things you already know. Parallel lines are lines on the same plane that never intersect. The arrowheads on the lines indicate that they are parallel. A linear pair is a pair of adjacent angles that form a straight line. The sum of the linear pair is always 180 degrees. Vertical angles are the angles opposite each other when two lines intersect. Here, your vertical angles are always congruent. Congruent angles are angles that have the same measure. Did you know that not all lines and planes intersect? Take a look at line AE and line BF. Since these lines are coplanar lines that do not intersect, they are parallel. This symbol means is parallel to. So if I read this sentence, line AE is parallel to line BF. Take a look at line AD and line BC. Line AD is parallel to line BC because they are coplanar and do not intersect. Skew lines are non-coplanar lines. They are not parallel, but they do not intersect either. Take a look at line AB and line CG. They are not on the same plane, but they do not intersect either. Parallel planes are planes that do not intersect. Take a look at plane ABCD and plane EFGH. Since these two planes will never intersect, they are parallel planes. A line and a plane that do not intersect are parallel. Segments and rays can be parallel or skew. They are parallel if they lie on parallel lines, and skew if they lie on skew lines. In example 1, we will identify non-intersecting lines and planes. For part A, which segments are parallel to segment AB? Well, here is segment AB. So we want to list all the segments that are coplanar to segment AB, but do not intersect segment AB. Let's start with segment CD, segment HG, and segment FE. Since these segments are coplanar to segment AB, but do not intersect segment AB, they are parallel to segment AB. For part B, we want to know which segments are skew to segment CD. Well, here's segment CD. Remember, skew lines are neither parallel nor intersect. Alright, segment BF is skew to segment CD. Segment AE is skew to segment CD. Segment EH is skew to segment CD. And segment FG is skew to segment CD. None of these segments are parallel to segment CD or intersect with segment CD. For part C, we want two pairs of parallel planes. So we can have the front and the back as one pair, the left and the right as one pair, or the top and the bottom as one pair. So let's just choose. How about we start with the left and the right? So the left plane would be plane ABFE, and it is parallel to plane CDHG. Next, let's look at the top. How about plane ABCD, and it is parallel to plane EFGH. Part D asks, what are two segments parallel to plane BCGF? Well, here's plane BCGF. There are more than two segments that are parallel to this plane, but we'll just name a couple. So remember, in order to be parallel, they cannot intersect. So let's take a look at segment AD and segment EH. Two other segments that are parallel to plane BCGF would be segment AE or segment DH. Pause the video and do you try number 1. For part A, which segments are parallel to segment AD, let's first identify segment AD. Now, in order to be parallel, we want them to be coplanar, but not intersect. So, segment BC, segment FG, and segment EH. These segments are all coplanar, but do not intersect with segment AD. For part B, we want to explain why segment FE and segment CD are not skew. Remember, in order to be skew, you have to be non-coplanar and not intersect. However, I have plane CDFE here. It is that diagonal plane from the top right to the bottom left of this prism. So segment FE and segment CD are not skew because they are coplanar. For part C, we want another pair of parallel planes. Since in the example we named the left and the right plane and the top and the bottom plane as parallel, let's name the front and the back this time. So the front is plane AEHD, and that is parallel to the back, or plane BCGF. For part D, we want two segments that are parallel to plane DCGH. So here's plane DCGH. Let's first look at the segments that are parallel to the sides, segment DH and segment CG. So segment AE and segment BF would be parallel to plane DCGH. And now let's look at segments that would be parallel to the top and the bottom of plane DCGH. So here I could have segment AB or segment EF. All four of those segments are coplanar to plane CGHD, and they do not intersect. A transversal is a line that intersects two or more lines. So here, line M is the transversal because it intersects line K and line L. Every time a transversal intersects two lines, 8 angles are formed. When the lines are parallel, special properties exist between the angle pairs along the transversal. We'll talk about those a little later. Transversals that intersect with two lines form interior angles, those are the angles between the two lines, and exterior angles, those are the angles on the outside of the two lines. Corresponding angles are in the same position when you slide them along the transversal. So look at angle 1. It is corresponding to angle 3. Angle 1 is above line M and to the left of the transversal K. Angle 3 is above line N and to the left of the transversal K. Angles 6 and angle 8 are also corresponding angles. When your lines are parallel, like line M and N are, note these marks show that the lines are parallel, our corresponding angles are congruent. So angle 1 would be congruent to angle 3, and angle 6 would be congruent to angle 8. Angles 5 and 7 are also corresponding, as well as angles 2 and 4. Alternate interior angles are angles that lie on alternate or opposite sides of the transversal, but are on the inside or interior of the parallel lines. Angles 2 and 7 are alternate interior angles. Alternate exterior angles lie on alternate or opposite sides of the transversal on the outside of the parallel lines. So angle 1 and angle 8 are alternate exterior angles. Alternate interior and alternate exterior angles are congruent when your lines are parallel. Angle 5 and angle 4 are another pair of alternate exterior angles. Angle 6 and angle 3 are another pair of alternate interior angles. Your same side interior angles, or consecutive angles, lie on the same side of the transversal, inside or on the interior of your parallel lines. So angle 2 and angle 3 are same side interior angles. Same side exterior angles lie on the same side of the transversal, but on the outside or exterior of your parallel lines. Same side interior and same side exterior angles are supplementary to each other. So angle 2 plus angle 3 will equal 180 degrees. Angle 5 plus angle 8 will equal 180 degrees. Angle 6 and angle 7 are another pair of same-side interior angles. Angle 1 and angle 4 are another pair of same-side exterior angles. This slide is just a quick reference of your angle pairs. Pause the video and try to find the measure of each angle if the measure of angle 1 is 55 degrees. Remember that alternate interior angles, alternate exterior angles, corresponding angles, and vertical angles are all congruent. Linear pairs, same-side interior angles, and same-side exterior angles are always supplementary. Here are the answers. How did you do? In example 2, we're going to identify angle pairs. Here, it asks us which is a pair of alternate interior angles. Well, we know that alternate interior angles are on opposite sides of the transversal, and they are interior, in between the two lines. So we know that angle 7 and angle 3 would be alternate interior angles, and angle 2 and angle 6 would be alternate interior angles. Since C, angle 2 and angle 6 are our only choice, that is our correct answer. Pause the video and do you try number 2. What are 3 pairs of corresponding angles? Remember, corresponding angles are in the same position along the transversal. So let's start with angle 1. Angle 1 is above the transversal, line R, and to the left of line M. So we want to look at an angle above line R and to the left of line N. Angle 1 and angle 3 are corresponding angles. Now let's look at angle 2. Angle 2 is above the transversal and to the right of line M. So let's look above the transversal and to the right of line N. Angle 2 and angle 4 are corresponding angles. Next, let's look at angle 8. Since angle 8 is below the transversal and to the left of line M, we want to look below the transversal and to the left of line N. Angle 8 and angle 6 are corresponding angles. Now let's look at angle 7. Angle 7 is below the transversal to the right of line M, so we want the angle that is below the transversal and to the right of line N. Angle 7 and angle 5 are corresponding angles. I know you only had to name 3, but here are all 4, just in case your 3 were different than mine. In example 3, we will classify an angle pair. The photo shows the Royal Ontario Museum in Toronto, Canada. Are the angles 2 and 4 alternate interior angles, same side interior angles, corresponding angles, or alternate exterior angles? Well, let's have a look. Since angle 2 and angle 4 are on the interior of the lines, we know that they are either same side interior or alternate interior. Since they are on alternate or opposite sides of the transversal, we know they are alternate interior angles. Pause the video and classify angles 1 and 3. Since angle 1 is above the transversal to the left of the line, and angle 3 is also above the transversal and to the left of this line, angles 1 and 3 are corresponding angles. Now is your chance to shine. Go ahead and complete the lesson check. Don't forget to check your answers. If you have any questions, ask me tomorrow in class. If you're feeling amazing about the lesson, like you really understand, go ahead and try the challenge. See how well you can do. Now that we're finished with the lesson, reread the learning goal, look over the scale, and see if you've improved from where you were before we started the lesson.